Well, how are you everybody who is watching this video? I would like to take this opportunity to welcome some physical ordinary diploma students who are pursuing ordinary diploma in electronics and telecommunication engineering. My name is Olenjolai. I would like to take this opportunity to welcome non-physical students into a very interesting class in departments of electronics, electronics engineering, and the module is called the electronics drawing. So I would like to take this opportunity to welcome beginners, to welcome the intermediate technicians and the engineers, and even statistics. Also, these are the very important in case you are dealing with electrical science or you are dealing with electronic science. So the requirement for this course is actually you should have drawing tools and you should have a fresh mindset, because as we discussed in previous lecture, we say drawing or electronics drawings is a technical language. When you talk about electronics drafting, it's actually about technical language. So I would like to ask you that to join us and stay connected point to point. In case you have any question, don't hesitate to ask it. Maybe at the beginnings of the class, or just in the middle of the class, or even at the end of the class. One thing which I want to tell you, that this is the safety precaution of myself, that when I'll be teaching, I want to tell you that I don't know everything about electronics drawing. I just know a small portion of it. I have a responsibility to teach others about electronics drawing. So that's what I want to tell you. I'm learning technical drawings in electronics and telecommunication engineering every day, or I'm learning just frequently. So for instance, yes, you can find that, okay, I learned these techniques 10 years ago, but there are some key concepts that I'm going to teach you. I just learned them in this week. So for me, learning does not have end. I don't know about you. But another thing that I thank God by His own grace, I am a local lecturer or just a local university teacher, but also I thank God because I am a national engineer, electronics and telecommunication engineer, and also I am a national teacher in technical issues in the entire country of Tanzania. We are going to use the syllabus of our own local institution, but I believe that there will be actual cross-cutting to other universities. So have a fresh mind. We have a very interesting topic that today we are going to start, that's called the block diagrams. When, for instance, you ask me about the block diagrams, I just want to tell you that that's the simplest language or technical language actually that engineers, electronics and telecommunication engineers use to present the information. Why? Because it's simple, and also it can give you the physical layout of the system. So we are going to learn, and I'm going to break the concept down. The first thing that we are going to define, and we are going actually to have a short discussion about block diagram. Then we'll be discussing about the four main parts of any block diagram. Then we'll discuss about types of block diagram. And finally, I will teach you almost 10 examples of electronics and telecommunication block diagrams. So I want to ask you that stay connected, because we are just starting a business. Let me appreciate some physical students. who told me that they really love electronics drawing and will realize it as long as we move. How are you, electronics and telecommunication engineering students?
We are fine.
How are you, electronics and telecommunication engineering students?
We are fine.
Well, are you ready for the second chapter?
Yes.
What the name of the second chapter?
Block diagram.
Block quality diagrams. And then what the names of the lecture?
Block diagram. Block diagram.
So because we are going to start a new topic today, we want to have quick review. Okay? We don't have a quick review. We are just diving directly into the concept. And the first concept that we have to learn, first of all, we have to learn the meaning of block diagram. What is block diagram? So you can take a few seconds to ask yourself this question. What is block diagram? So just take take just 30 seconds to ask yourself, what is block diagram? Once you are done, then ask your neighbor, what is block diagram? So what's a block diagram? Block diagram is a block diagram. Yeah. So it's a good try. Okay. So different sources in electronics engineering define this terminology by using different styles. So I'm going to teach you 3 definitions of block diagram because this is the one, we call it a cornerstones of electronics and telecommunication diagrams. So a block diagram, again say block diagram. Again say block diagram.
Block diagram.
Again say block diagram.
Block diagram.
So a block diagram is a type. So a block diagram is a type. A type of what is a type of electrical diagram. So we have different types of electrical diagrams as we discussed in chapter 1. Is a type of electrical diagrams or electrical drawings. Electrical diagrams or electrical drawings that represent represents the principal component. That represent the principal components. Principal components. So the principal components of what? The principal components of a complex electronics system. Complex electronic system in the form of blocks. In the form of blocks which are interconnected. Which are interconnected together by arrows, by lines. So this is one of the simplest definition of a block diagram. So stop writing because you have to reinforce understanding. Class again say block diagram. So what is a block diagram? Well, a block diagram is a type of electrical diagrams or electrical drawing that represents, what does it represent? The principal components. Say principal components. When you talk about principal components, it doesn't mean that electronics component. There's a difference between principal components and the electronics components. So don't think that in that definition we are talking about the electronics components such as resistor, capacitor. No, we don't have resistor or capacitors in block diagram. Are we together? So you say that principal components means that the main part of the system, the main subsystem. That's what that's the meaning. Okay? Yes. Are we together?
Yes.
Of what? Of a complex electronics system. A block diagrams may represent either a simplest electronic system or maybe actual that we call it a moderate electronic system or a complex electronic system. Then how do we represent those simplest or simple and the moderate and even complex electronic system by using block diagrams? Well, we are going to use just the blocks. Say blocks. Say blocks. And these blocks are interconnected logically together by what? Lines. Say logical. So interconnected, because you don't connect it the way you wish, logically. And I want to tell you that separating. I want to tell you that if you are pursuing ordinary diploma of 3 years in electronics engineering or electrical engineering or any other electrical related field, then in your third year you will be actually asked to find a real life problems, and you have to propose your solution, and that one or that course we call it project conceptualization and project realization. So you'll build the system, you'll be implementing also that project. If you say that maybe I want to make a system that actually count the number of the students entering the class, or maybe I want to just to make a smart class attendance, right? So in that sort or in that modules, the very important part, you will be drawing a block diagram for that system that you are proposing. Are we together? So the information I'm teaching you, I will be teaching you slowly, clearly, with the simplicity, and actually that by using different tricks, because so many students in third year, they fail to draw a good block diagram. Right? Right? But because you don't know the principles of drawing block diagram, what should we follow? At the end of this topic, I will ask you, just give a challenge, just go and visit any third year students in any course, is electrical engineering or biomedical, computer or electronics, and then ask them to show you the year project book or the year project report. Then you realize what I'm teaching you. Okay? Because I think that you'll be having some corrections to that system. So he said that because when you say interconnected, then you know some students, they might think that you just draw lines. No, those lines should be or those blocks should be interconnected logically. They should be interconnected logically together by what? By lines. Are you together? Is it clear? Is it clear? Yeah. So that one source define a block diagram in this time. Another source define this important terminology that's called a block diagram. So a block diagram is a diagram. Is a diagram. So a block diagram is a diagram of a system. So this is the diagram of a system in which the principal parts, or the principal functions, or the functions, in which the principal parts or functions are represented by blocks, connected by blocks connected together by lines to show the relationship, of the blocks. So some of the sources define block diagram in this style. So stop writing. Let us reinforce understanding by reading the first definition. 1, 2, 3, read.
Block diagram is a type of electrical diagram that represents the principal components of a complex electronic system in the form of blocks which are interconnected logically together by lines.
So the second definition, stop writing, let us discuss the second definition. A block diagram is a diagram. First of all, it's a diagram. Say it's a diagram.
It's a diagram.
So it's a diagram of what? Of a particular system in which the principal parts, here we use the principal components. In this definition, we use the principal components. You may use the vocabulary of components or the parts, or the principal function or the function. Say function.
Function.
So you see in the first definition, there is no this important term that called the functions, because those blocks will be representing function executed by that complex system. For instance, we as a human being, we say that it's an entire system, it's a complex system, right? So let's say that what the function of the hand, I believe that you know the function of the hand is different from the function of the leg. Isn't it?
Yes.
The function of the teeth, I know that's different from the function of the ear, right?
Yes.
So the block diagrams actual, when we take the electronic system, whether it is simple or intermediate or complex, we have to break it down into different blocks or different sections which perform particular function. It's just like the human beings. We say that how many systems do you have? How many biological systems? Or how many human biological systems do you have? I think that's 7, right? The first one, coordination system. The second one, expression. And the third one, reproductive system. Tell your neighbor, reproductive system. Tell your neighbor again, reproductive system. I can tell your neighbor, reproductive system. Then digestive system, right? Yeah. So those are just some system perform particular function. Digestive system is actual digest the food which has been taken. Digestive system cannot perform maybe the interpretations of the signal which has been sent to the brain. Or digestive system cannot perform the circulation of the blood. Are we together? Are we together? So this terminology of function is very important, because yesterday we had a first mini presentation for the bachelor students who are pursuing electronics and telecommunication engineering. And actually, when you analyze the block diagrams, they were very poor, because some of the blocks, they don't represent the function. Some of the blocks just representing something else, so they're just representing the components. So these function or principal parts are represented by what? Blocks. And these blocks are what? Connected together by what? Lines. To form what? To show what? The relationship of the what? The relationship of what? So it means that our biological parts also, they have their relationship. They do relate when they function. Or for instance, when I'm teaching you now, all my biological system, or many of my biological system, they are actual cooperating together to help me to teach you. Are we together? Are we together? 1, 2, 3. Read the second definition quickly.
Diagram is a diagram of a system in which the principal parts or functions are represented by blocks connected together by lines to show the relationship of the blocks.
Again?
A block diagram.
Loudly, please. No. Loudly. 1, 2, 3. Read it loudly.
A block diagram is a diagram of a system in which the principal parts or functions are represented by blocks connected together by lines to show the relationship of the blocks.
Did you understand? Did you understand? So a block diagram, if you have a question, just wait, you'll ask him. A block diagram in electronics engineering. A block diagram in electronics engineering is a visual representation. Is a visual representation of what? Of a system. is a visual representative of the system that shows the major component, the major, not the minor, the major components. That shows the major components. That shows the major components or the major subsystem. The major subsystem and the functional relationship. And the functional relationship. And the functional relationship. That's the third definition of a block diagram. Okay, so we have the third definition. Let us discuss about this third definition. Why am I providing you so many definitions? Because I want you to be, I want you to understand block diagrams rather than to cram. Because you have only two options, either to understand, you have three options, either to understand or to cram, or actual neither understanding nor cramming. So you have only three options, A, B, C. And you're the one who has response. Wait. What did I say? He wasn't in the class. So let us discuss the same definition. It doesn't mean that, even you know that sometimes some of the teachers, they just come, they write the terminology, they go into too much detail. They don't even define. Right? So giving you three definitions, my intention is to transform you from cramming educational system to understanding educational system. Because if you some of the students might understand this definition rather than this one, and some of them might understand the second definition rather than the third one, or maybe others they might understand the third definition rather than the previous two. But actually defining the terminology with by using different sources, it gives you a broad knowledge about it. For instance, in the third definition, actually it gives us some important information which actually the first and second definition did not discuss about it. Are we together? So the third definition, the author said that a block diagram in electronics engineering is a visual representation. Say visual representation. So we have visual. So what the means of visual representation? Visual and there is a virtual and visual. I think that for the students, they like a lot to use VPN. VPN is visual private network. Virtual. And this is visual. So the difference is yada. Oh, okay. Okay, so he said that this gives us visual representation. So in the first definition, we had the word represent, but there's no an adjective for 40, an adjective for full of the visual. So this is the visual representation of what of the system that shows what the major components, or I say the please concentrate, stop writing, stop doing whatever you're doing, look on the blackboard, listen. So let me repeat. A block diagrams in electronics engineering is a visual representation. Say visual representation. So it means that this is the actual representation of 40 of the system. How does it represent? Well, it shows major components or major subsystems. Say major components or major subsystems. I can say major components or major subsystems. Good luck, you will be saying yourself until the end of this class. So when you say that major components means this the entire system, it consists of different components. And remember that this word components, it does not mean electronics components. No. It means parts. Okay? Or in other words, it shows what major subsystem, because it depends on the type. Some of the block diagrams might have major subsystem, and some of them might be too much detail, where actually they represent even minor subsystems. Then, And they are what? This is the very important. And they are what? It's saying functional relationship.
Functional relationship.
Say functional relationship.
Functional
So
relationship.
from these keywords, functional relationship, it means that, for instance, if you have block 1 here and you have a block 2 here, so this block 1 and block 2 will have functional relationship. And then maybe we have block 2, which is interconnected with block 3. So the second block and the third block, they have what? A functional relationship. It means the ear function are relating. And if, for instance, you draw arrow from first block to the second block, and then to the third block, it means that this block will perform a particular function, and the outputs of this block will be the inputs of this block. And the outputs of this block will be the inputs of another block. That's the meanings of functional relationship. Are we together? Okay, so 1, 2, 3, reinforced understanding. Read the set definition.
A block diagram in electronics engineering is a visual representation of a system that shows the major components and subsystems and their functional relationship.
So read, reinforce the first definition to the last. 1 and loudly. And you have to stop doing everything you are doing. 1, 2, 3, go.
A block diagram is a type of electrical diagram that represents the principal components of a complex electronic system in the form of blocks which are interconnected logically together by lines. A block diagram is a diagram of a system in which all functions are represented by blocks connected together by lines to show the relationship of the blocks. Or a block diagram in electronics engineering is a visual representation of a system that shows the major components or subsystems and their functional relationship.
Good. So this is just a detailed discussion about block diagram. So that's another informative sentence about block diagram. So we say that each separating each block, say each block. So we might have, it depends the size of the block diagram, we might have 3 blocks or 4 blocks or 5 blocks or even 10 blocks within the single block diagram. So it depends to the system which has been represented. So each block in the block diagram represents specific function. Say specific function. Say specific function. So actually we have general functions and specific function. So when you say specific function, for instance, the specific function of my hand, let's say it's writing. Okay, the specific functions of my ear is actual to hear the signal within the human audible range, that is 20 Hz up to 20 kilohertz. Right?
Yes.
Right?
Yes.
Right?
Yes.
Or specific process. We have process. Sometimes some of the electronic systems, they might have a number of process. And the lines that we find in block diagrams connecting these blocks indicates,
indicate
how the signal or data or energy flow between these blocks. So you can find that this sentence is very important because actually it's giving you some more information that did not mention or we did not mention in the definition. What are the more information? For instance, in this definition, we mentioned about function. In the first definition, in the second and third, but we did not mention about process, either specific function or specific process. So this is the additional. We added the value. And then also, we say these lines interconnect them logically. But we did not say that what the message carried by those lines. So in this sentence, we can learn that the message carried by these lines are either signal, say signal, say signal, or data, or that, say data, or energy, say energy. So that signal may flow between one block to another, or from one block to another block, or data may flow from one block to another block, or electric energy may flow from one block to another block. Are we together? Yes. Are we together? Yes. The second sentence, the second important sentence. The block diagram, first of all, before I continue, is there any question about what we've discussed? Because I gave you a promise. I am the teacher who loves questions from students. I like questions more than teaching. So now let me give you a chance for the physical students to ask me questions about what we've discussed. Students, ask questions about what we've discussed. Jackson, welcome. Can you give him a microphone? Quickly. Turn it on. Or is it on? So Jackson has the question. You are welcome. Can you speak loudly and please position the microphone here?
Yes, I was asking in this...
Position the microphone nearby your mouth.
I was asking in this chapter of block diagrams, in every project that we are going to do as the electronics students, are we going to use these diagrams which we are learning in block diagrams? In every project, any project which we are going to do, is it a must to use block diagrams?
Pardon? Can you repeat?
In any project after we have reached
the end of this topic.
The third year. Are we going to use those block diagrams which we are learning today?
So your question is, are we going to use block diagrams in your learning process?
In learning process, in the performing projects.
In performing?
Projects.
Projects?
Yes.
Yes, the answer is yes. Block diagrams are used in any issue of electronics engineering. Block diagrams are drawings in the final year project. Block diagrams are drawings in the research. Block diagrams are drawings in the any design. Block diagrams are drawings even in different electronics components. Okay? That's why you call this the very important technical language. Are you together? Yeah. So thank you, Jackson, for your question. Another question? So the message I'm teaching you while you're in first year of ordinary diploma in electronics and telecommunication engineering, preserve it or store it for the rest of your life. What I'm teaching you, once you go to the higher education level, maybe undergraduate or bachelor degree in telecom or in electronics, you will remember what I'm teaching you now. Once you go for your postgraduate studies, maybe masters in telecommunication engineering, or masters in optronics, or maybe masters in optical, maybe masters in electromagnetics, or in wireless, or in 5G, or in broadband communication system, and whatever, you will find a number of block diagrams. Even if you will be pursuing your PhD, Doctor of Philosophy studies, maybe in what? In signal processing, in digital signal processing, you will encounter a number and even advanced block diagram. So what I'm teaching you in ordinary diploma, store it for the rest of your, whenever you go any industry, there is the instrumentation, even in Tanzania. When you go to our local industry, we have a department that's called instrumentation measurement. You'll find a number of the measuring instruments and even testing instruments. Those measuring instruments and testing instruments, they actually accompanied by user manual. And the user manual, something the manufacturer might use the diagrams to teach you about how to use that particular instrument. Angelica, you're not in the class. Then, the block diagram, is a part. So this is a part. Is a part of what? Is a part of electronics. So this is the part of electronics, technical. Is a part of electronics, technical language. Part of electronics, technical language. It's a part of electronics, technical language used to communicate. Used to communicate. Used to communicate your team the high level overview of electronics or telecommunication or electrical or computer or mechatronics, engineering system. So this is the part, subwriting. So the block diagram is a part of electronics technical language used to communicate. To communicate what? The high-level overview. Say high-level overview. Of either electronics engineering system or telecommunication engineering system or electrical engineering system or computer engineering system or mechatronics engineering system. So you say that the high level, it's less detailed. That means of high level. Less what? Yes, less detailed. However, that we'll discuss this in detail in two types of block diagram. We have general block diagrams and also we have detailed block diagram. We'll discuss it in the next lectures. Are we together, class? So when you say it's a part, for instance, we say you have English language. In English language, you have different parts. One of the parts is grammar. Say grammar. Say grammar. The second part of English language is what? Literature. Right? So grammar is just a part of English language. It's not the entire English language. So similarly, in electronics drawing, as we discussed, we have different types of electronics drawing. Right? We have block diagram, and another one is what? Another type is what? Functional block diagram, the other type is what? Other types of electronics diagram. Wiring diagram, then you are my friend, because you've been watching somewhere else to say that teacher, don't see me. Pictorial diagram. Then another diagram, Nehemiah. Detailed layout diagram. No, detailed layout PCB. Then brother there. Assembly diagram. Then the other diagram is what? Schematic diagram. Another type of diagram. Circuit diagram. Another type of diagram. Schematic circuit diagram. So because you have different types of electronics drawing or electronics diagrams, then block diagrams, it's one of the types. So it's a part of the electronics technical drawing language. Are we together? But this part play a very important role. Actually, to give you the high level overview. Say high level overview.
High level overview.
For instance, the first day I met you, I just introduced myself. It's the first time to meet. So you just see, maybe at the end of the lecture, you say, okay, I know Olenjolai. But I think that when you've been meeting oftenly, you realize that you don't know Olenjolai. Similarly, myself, when I met you for the first time, I assumed that I know Diana, I know Angelica, I know Swale. But as time goes, when I'm learning more about Swalehe's language or Angelica's language or Jackson's language, I realize that previously I just had a high level knowledge. It means a shallow knowledge about you. Are we together? So it's very important to note that. So the block diagrams, where are these block diagrams are used? The block diagrams, and that's the important sentence. The block diagrams are heavily used in engineering, hardware design. So it means that these are used in different engineering, hardware design, So let me just mention them this time. Design, engineering, hardware design. Also these are used in electronics design. In electronics design. These also are used in software design. But also block diagrams are used in process flow diagram. And also they are used in process flow diagram. Process flow diagram. This is another important sentence about engineering, about block diagram. Okay, so this is another sentence operating. The block diagram, we don't have S here. Say the block diagrams. These are heavily used where in electronics design, in engineering hardware design, in software design, and process flow diagram, and even in control system design. So there are so many applications of block diagrams. We cannot even have enough time to mention them. Because before we design electronics product or electronics component, we should draw the block diagram first of its architecture. Are we together?
Yes.
Are we together?
Yes.
So I want you to reinforce this sentence in your mind. It's very important for you to know that this is the part of the electronics technical language. Or it means that electronics technical drawing language. So electronics technical drawing what language. So 1, 2, 3, read that sentence please.
The block diagram is the part of electronics technical drawing language used to communicate the high-level overview of electronics, telecommunication, electrical, computer, mechatronics, engineering systems.
Again, another important sentence that you have to remember, or you should adopt it to understand the block diagram. We say a block diagram gives generality overview. So gives general overview of electronics idea. Of electronics idea of how the individual how the individual subsystem work together to achieve, how the individual subsystem work together to achieve the main goal, to achieve the main goal of the system. These blocks, another sentence before we dive into another important part. These blocks are interconnected together by using lines interconnecting lines with arrows, by using interconnecting lines with arrows to show the signal or energy flow among the blocks. These are very important sentences before we discuss in detail about block diagram. So the first, separating, let us discuss. Let's say this is the first sentence, second sentence, third sentence. And this is the fourth one, this is the fifth one. Listen, I say stop writing. Tell your neighbor stop writing, please. Ask your neighbor, do you understand block diagram? Answer your neighbor's question. Okay, so a block diagram gives general overview. Say general overview. Say general overview. For instance, I just meet you and then I tell you that my name is Olenjolai. I'm teaching. That's the general information. My name is Olenjolai. Well, it might be a specific. I've identified myself from other, maybe Olenjolai, or from other Tanzanians or other people. But the second sentence to introduce about my work or my job, then I'm telling you that I am teaching or I am a teacher. So the next question, what are you teaching? Are we together? The next question again, where are you teaching? The next question again, how are you teaching? So when I tell that I am a teacher, I am an engineer, it's general. So similarly, block diagrams always will give you about general overview. Say general overview. Block diagrams will never tell you about the details, about electronics components that you are going to use in implementation of your circuit diagram, or implementation of your schematic diagram, or implementation of your schematic circuit diagram, or maybe in your electronics drafting about designing the PCB layout, or maybe about how you are going to mount the electronics components. It doesn't tell you about that. Then it gives us the general overview of what electronics idea. Say electronics idea. About what? So general overview of electronics idea. Then in which part? Then of what? Of how individual subsystem. Say individual subsystem. Say individual subsystems. So work together to achieve the main goal of the system. The main goal of what? The system. For instance, ask your neighbor, what the main goal of your body? Because the human body consists so many systems, right?
Yes.
So ask your neighbor, because you are learning about the main goal of who? Maybe the electronic system. But why should we learn about the main goals of electronic system while we don't know about the main goals of our own electronics body? So ask your neighbor again, what the main goal of your body? Please ask your neighbor, talk to your neighbor, socialize. Establish socialization. Talk to your neighbor, please. What the main goal of this body? Touch it. In order to remind him that even my friend asked him that question. So touch your neighbors. What the main goal of this body? So what the main goal? So the main goal is what? To eat what? Pilau. The main goal of your body to eat pilau, isn't it? Or the main goal of your body is actually to study, isn't it? Some of them. But all of the responses are wrong. The main goal of your body is to be alive. If you are not alive, then you know what will be next, right? So that's the main goal. So in order to be alive, then all other subsystems of your body have to work together to achieve the main goal of your body, to be alive. Do you know that your body doesn't like to die? Ask your neighbor, does your body like to die? The response, there's no need to think. You don't know. I have a gun in my office. Do you allow me to take it and kill you now? So for instance, in our bodies we have what? Digestive system, right? So then for the entire body, this is subsystem. Hello? Then in our bodies we have what? Reproductive system. Say reproductive system. Then in our bodies we have what? Transport system, blood transport system. Then we have breathing system, right? Then we have what? Excretion system. Say excretion system. Ask your neighbor, do you like excretion system? Are you sure? Okay. Excretion system. Then another system is called what? Coordination system. Say coordination system. Then another system is called what? Pardon? Nervous system. Very good. Another system? Refractive. Lymphatic system. So lymphatic system. Another system? Locomotive system. You forget locomotive system. What if your locomotive system is not working? You cannot come to the class. So this is a subsystem for your body. Digestive system is a subsystem. This is the second subsystem. Hello. This is the third subsystem for your body. Fourth subsystem, fifth subsystem, sixth subsystem, seventh subsystem, eighth subsystem, ninth subsystem. The main goal of all of these systems to work together in order to support you to be alive. Hello, brother, are you happy? Are you happy? Sure. Please smile before your neighbor. You see? Expensive smile. Are we together? So similarly, in electronic systems, whether complex or simple, you may find that you have a number of subsystems that they have to work together to achieve the main goal. Are we together? For instance, ask your neighbor, what's the main goal of your mobile phone? I don't think if your neighbors know the main goal of your mobile phone. What are the main goals of your mobile phone? Ask again your neighbor. Because you are learning about the main goals of the system, but you don't know even the main goals within, surrounding your environment. So the main goal of your mobile phone is to make a call. Mobile phones are not made in order to share data. Mobile phones are not made in order to send text or to actually to enjoy the social network. No. The primary goal, the common or the first human problem is how to transfer the voice signal to the distant destination. That's why that those we call it telephones, TTCL telephones, they don't have a lot of features. They just give you a chance to make a call, that's all. Do you know telephone? We have mobile phone and telephone. Say mobile phone and telephone. So mobile phone, actually it's the one that you are carrying. When you talk about telephone, it's the one that has to stay in the office. Okay? Okay? So the primary goal of a mobile phone or a telephone is actual voice communication. It means to make and receive a call. That's all. All the other features within your mobile phone have been added as technology has been growing or emerging. Are we together? For instance, in telecommunication, because you have, let me just give you this flavor. Tell your neighbor, are you ready to receive the new flavor? Ask your neighbor, are you ready to receive a flavor? So for instance, in telecommunication, in cellular network, we have generation. We have 5G, well, the first G, then we went to the 2G, then we went to the 3G, then we went to the 4G, then we went to the 5G, then we went to the, now we are heading to the 60G. And this G, you don't know what the meaning. This G means that 1 gigahertz, this is the carrier signal, this is 1 gigahertz, and this is 1 gigahertz, and this is 1 gigahertz, 4 gigahertz, this is 1 gigahertz, 2 gigahertz, 3 gigahertz, 4 gigahertz. Then this is 540 gigahertz. And then this is 640. So we are heading to the 60 gigahertz. So right now your mobile phone supports 3G. Some of them are supporting 5G. So I don't know about your mobile phones, what generations does it support. So they talk about in each of the generation, there are some added features. Are we together? Are we together? You just use here 5G. Now Airtel, we are moving to the 5G. But you don't understand what it means of 5G. This is carrier signal. But it's not the concern with electronics. It's just a flavor. Tell your neighbor, it's just a flavor. Salt is not an important food, but it's just a flavor. And if you miss it, you know what will happen. Huh? Then, the second sentence says that these blocks are interconnected together by using what? Interconnecting what? Lines. Say interconnecting lines. Say interconnecting lines. But the condition of these interconnecting lines, they should have arrows. Either on one side or on both sides. Depends on the system presented. Then, to show what these arrows show actual. Remember in the previous sentences, we did not mention arrow. But it's very important. Because arrows show the direction of the signal between the blocks. Okay? If you just draw the line, for instance, you just draw this block, you call it, this is what? So this is a sensor unit, for instance. And this block is control unit. Then you draw a line. You will not understand where the information flow from sensor unity to this, from this block to this block. Or information flowing from this block to this block. Or information is two-way system. It actually flows this side to this side, or this side to this side. Or information just flow from the sensor unity towards the control unit. Or maybe the information might be flow from the control unity to the sensor unit. So it means that this is still general. And actually that it creates some questions where the directions of the signal. But for instance, if I draw or I include the arrow, just like this one, then well, hello, 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 malaika, 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 malaika. When we draw an arrow like this one, it gives you the unique directions of what? Of the signal. Right? Or unique directions of what? Of the data. Or unique directions of what? Of the energy. It's flowing from there, this block to this block. Are we together? Because some students, you find they draw block diagrams and they're just using lines. Angelica, again, Angelica is getting out of the class, getting in. Getting out of the class, getting in. Class, are we together? Is it clear? I believe that now you have a very important introduction concept about block diagrams, isn't it? Well, so if you've understood about everything that I have taught you, before I dive into the second part of this lecture, then let me ask you questions, or let me give you a chance to ask me questions about what you've discussed. Hello, Mr. Of course. Stand up. Question. Question. Ask you questions. So if there's no questions, that is good. Then now let us dive. Let us discuss in detail. That's all about introduction of block diagrams. Let us get in, or let us get into in depth of the block diagram. I don't know, but I think that in the academic year of 2026 to 2027, you'll be doing your final year project. I wish if I could be there to see your block diagrams of your project. Now, this is 2024, 2025, first year. 2025, 2026 is second year. 2026, 2027, third year. So I wish to see your block diagrams to actually to notice if you have understood and keep what I've taught you, or you've been just learning for the purpose of passing exam. Then now, ladies and gentlemen, let me teach you about 4 main parts. And I want to tell you that there is no any book, there's no any single book or single document or single article explaining about what I've been teaching you in each chapter systematically. I use different sources, and I have to sit down to arrange the information in ascending order or in systematic order. Right? Yeah. So even the books that we have mentioned in lecture 1, they cannot just actually teach you just in this arrangement, because you have to read different books, and even some of the books are not mentioned there. Some of the sources are not mentioned there, but they can provide important information. So 4 main parts, say 4 main parts. I can say 4 main parts of 40 electronics, because also you can have electrical block diagrams. Electronics block diagram. We will not finish this concept in this lecture, but in the next lecture, which is lecture 2, also we'll discuss about it. Class say 4 main parts of electronics block diagram.
4 main parts of electronics block
I
diagram.
can say with joy, 4 main parts of electronics block diagram.
4 main parts of electronics block diagram.
So mostly electronics block diagrams, mostly electronics block diagrams have 4 main parts that make the entire block diagram meaningful. That means you can draw a block diagram without including the 4 main parts, but your block diagrams will fail to communicate some of the information of that particular system. Hello? So you say most electronics block diagrams have how many parts? How many parts? You should or you must include those 4 main parts in any block diagrams that you are drawing. Unless, otherwise, your block diagrams will be meaningless. Because this is the language. For instance, in grammar, you have to follow grammatical rule. Right? When you are composing a sentence, maybe you have to start with a noun or pronoun, then followed by a verb. Right? You cannot compose a sentence and then say that this sentence will be formed by a noun and the adverb. Yani huwezi ukawa na sentence ambayo ina nomino na kielezi. Because you forgot even Swahili. But you can have a sentence that consists in a name and the adjective. Okay. So the following are the 4 main parts of the following. Are the 4 main parts of the electronics block diagram. The first main part, a block diagram must have blocks. Say blocks. Say blocks. Then any block diagrams, any electronics block diagram must have lines with arrows. Lines with arrows. Then any block diagram must have, so you say that lines with arrows. Any block diagram must have labels. Labels of the blocks. So you say that labels of the blocks. Labels of the blocks. Labels means that label, yes, label of the block. Then the first part, any block diagram must have figure number and the name of the block diagram. I want to tell you that I used it to teach block diagram to the number of classes, physical and even online. But let me tell you that you have been exceptional class, that actually I have planned to teach you block diagrams in a different style that you'll never forget for the rest of your life. If I could be you, I could say thank you God, thank you sir, and even I could clap hands. But because we are in Bongo, say we are in Bongo. So in Bongo, people always have something with quality. We have a very interesting song. Are you ready to sing the song? Are you ready to sing the chorus of the song? Yes, because block diagrams is just like a chorus in the song. And this is the very interesting song for the Tanzanian, which has been sung so many years, and actually it gives us a message for the rest of our life. Are you ready? Iyo, yo, 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 iyo, yo, 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 yo. Mwenye wivu ajinyonge sana. Oh, mwenye wivu ajinyonge sana. Iyo, yo, 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 iyo, yo, 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 yo. Iyo, yo, 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 iyo, yo, 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 yo. Mwenye wivu ajinyonge sana. Sing, mwenye wivu ajinyonge sana. Sing again, mwenye wivu ajinyonge sana. Sing for your neighbor, mwenye wivu ajinyonge sana. So one of the problems we have is jealous. Getting? So these are the 4 main parts. I want to tell you this is the truth, because I want to tell you that there is no any class that I have taught them block diagrams in this style. I taught last year a module called the electronics product fabrication for the ordinary diploma in level 60 or 3rd year, and also the first undergraduate students. I taught them about block diagrams, but I did not go in detail and even just the introduction and have the clear texture. We just discussed the, with some examples, but I did not clarify. I hide some of the information. But then, right now, God said that, okay, unhide the information. Okay? Yeah, because we are Bongo students, we'll appreciate when Olenjolai die. Okay, so any block diagrams or any electronics block diagrams should have what? Blocks. Say blocks. Blocks. Say blocks. Blocks. Hello? Hello? Mister, sit down. So a block diagram without blocks is meaningless. When we talk about blocks, we mean plural, more than one block. Okay? Any block diagram should have lines with what? Lines with what? And any block diagram should have what? Say what? Say label.
Label.
Say label.
Label.
Label, actually, it's the name of the block. It's not the name of the block diagram. It's the name of the particular block. Then any block diagram should have figure number or the number of the figure number and name of the block diagram. That's all. You see how simple it is?
Yes.
Huh? Yeah. Class, are we together?
Yes.
Are we together?
Yes.
Yeah. So it means that let us discuss today the first part. In lecture 2, we'll discuss the second, the third, and the fourth part. So stay connected. Number 1, blocks. Say blocks. Whether you're saying hey, huh, he, huh, ah, we are continuing. You don't change anything. He, say blocks. Blocks. Write down. You are taking photo. Second question. What is the meaning? What is the meaning of the? What is the meaning of the? What the meaning of a block? What is the meaning of a block in electronics? Electronics drawing. So simply, this is our intention. What the meanings of a block? When you hear the word block, say again block. Block. Say block. Block. Okay, ask your neighbor or ask yourself, what is the meaning of block? You mentioned block, 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 block. Block diagram, block diagram. Okay, you know the meanings of block diagram. But what are the meanings of the word block? So for you, you just remember block 3, eh? Or block 1. Block 2, eh? Block 2, block 3, block 1. Eh? So what the meanings of block in electronics? Okay, ask your neighbor. And write your neighbor's definition. Malaika, ask your neighbor, please. You didn't see your neighbor's smile. I think you've seen it. So, in electronics engineering or in electronics drawing, keep quiet. In electronics drawing, a block. Say a block. Say a block. Say a block. So a block typically refers to a symbol or a diagram, a symbol or diagram representing a distinct functional unit. A distinctive functional unit or subsystem within the system. So this is the simple definition of a block. So a block in electronics drawing, a block typically refers to the symbol or diagram representing distinctive functional unit or distinctivity subsystem within the system. Within the what? The system. Okay, so he said that separating in electronics drawing or in electronics engineering, a block typically means that is a symbol. Say a symbol. Say a symbol. Is it called a symbol or a symbol? I'm talking to you also. Why you are not answering my questions? Huh? Is it called a symbol or a symbol? Huh? Symbol is what? American English or British English? Which type of English are you talking about? Are you speaking British English or American English? Or none of them? Yes, I know some of them, none of them. We have American English, we have British English, we have Africa English. For instance, our Tanzanians English is Kiswa English. Kiswa? Yes. So a mixture of Kiswahili and the English. Unajua bwana, you know. So it's a symbol or diagram? Say diagram. So a block itself, it's a diagram. But this symbol or diagram representing what? A distinctive functional unit. Say distinctive functional unit.
Distinct functional unit.
Unity means one. Right? So a distinctive functionality unit. It means that within that block diagram or a block diagrams actually representing different blocks which actually performing different functions. So each function will be represented by a symbol or a diagram that called a block. Are we together?
Yes.
Are we together?
Yes.
Or subsystem within what?
The system.
Class, are we together? Are we together or we are not together?
We are together.
So, the block or the blocks in electronics, the blocks in electronics engineering are used to by beginner or professional engineers and the technicians to visualize what? To visualize how different subsystem of the entire block diagram, how different subsystem, visualize how different subsystem of the entire block diagram interact together. Interact together. So blocks are very important in electronics engineering. You have a question? No, just forget about that. So blocks are in electronics. So we are talking about blocks. We are not talking about block diagram. Say blocks. Say blocks. So the blocks in electronics engineering, even telecommunication engineering, electrical engineering, are used by what? Are used by, I forgot by engineers. Yes, no. Are used by beginner, say beginner, or professional engineers and technicians to visualize how different subsystems of the entire block diagram interact together. Say visualization.
Visualization.
So remember that the block diagram is actually represent the visual. The visual the visual of the particular electronic system. So this is a very important sentence, because once you know the definition of blocks, then the next question: why do you need them in electronics? Why do you need them? So one of the questions, it can help you to visualize the functionality and also the functionality and the operations of the system. Are we together? And because we'll prepare 10 examples. Say to your neighbor, our teacher will prepare 10 examples of block diagram. Tell again to your neighbor is unhappy. Tell my neighbor, our teacher will prepare 10 examples of block diagram. And then I will give you an assignment to find your own 10 block diagrams. When you have been taught well, you'll be given a very good assignment. That's the disadvantage of being taught well. Right? When you'll be taught badly, you know, it's vice versa of that. You'll be just given an assignment which is simple. You may do it within 5 minutes or within a day, then you have finished it. Okay, so that's the important sentence. So, class, reinforce these 4 main parts of the block diagram. So even tonight you have to dream about these 4 main parts, because if you dream them or you wake up, the next day, that will be Friday, when you wake up, you think about the 4 main parts of the block diagram. Then Olenjolai has succeeded to write a block diagram in your mind. Because always, as a human, whenever we wake up, something click in your mind. Something click in your mind, whether it's bad thing or good thing. So that thing which will be given the first priority in your mind, it is something which has been written clearly in your mind. So you are thinking about that. Are we together? So 1, 2, 3, 4, go. These 4 main parts, read them. Read first time, second, third, until you write in your mind.
Second line. Labels of the block. Figure number and name of the block diagram. Labels of the blocks, figure number and name of the block diagram. Labels of the blocks.
So loudly, powerfully, 1, 2, say blocks. Lines with arrows.
Lines with arrows.
Label of the blocks.
Labels of the
Figure number and name of the block diagram.
figure number and name of the block diagram.
Can you check your neighbor? Your neighbor was just ceasing. No blocks, no label. Okay, now let us discuss about features. Say features. Say features of the block. Say features of the block. So what are the features, common features of this block? Number 1. First of all, you have to know about the shape of those blocks. Because you have different shapes. In real life, you have different shapes. Tell your neighbor some shapes that you know. Ask your neighbor, what's your shape? Yes, ask your neighbor, what's your shape? Describe your shape. Okay, so stop writing for the discussion. We are going to end this class soon. The first one, the first feature, stop writing, stop writing, stop writing. Tell your neighbor, stop writing. And listen, because this is very important features. Say features of the block. So features of the blocks. Let's say features of the blocks. I said listen and look on the blackboard. Number one, the first feature, the common shape of the block or of the blocks of the blocks used in electronics engineering or telecommunication engineering is what? Rectangle. Say rectangle.
Rectangle.
Say rectangle.
Rectangle.
However, that in some applications such as networking or computer system, the blocks may have other shape. The blocks may have other what?
Shape.
Such as what? Parallel or what? A cycle. So what the shape of the parallelogram is just like this one. You will see especially in flow charts. What the shape of the cycle? This one.
Oval.
Are we together?
Yes.
Are we together? Yes. Then the second feature, each subsystem, say each subsystem.
Each subsystem.
Of either a simple a simple or complex electronic system. Either simple or complex electronic system. Electronic system or telecommunication system is represented by what? By a block. By a single what? Block. Then the third feature, the block can represent a complex unit. Usually a block has representing a simple unit. It means that a particular unit or a particular collection of electronics components performing a particular function. But sometimes a block may represent a complex unit. Say complex unit.
Complex unit.
Say complex unit.
Complex
I will show you the complex unit. Means the complex unity is actually it's a unit which consists of some other blocks within it. Okay? Okay? For instance, if you talk about digestive system, say digestive say digestive system.
Digestive
there are
system.
so many organs responsible for the digestion, isn't it?
Yes.
Yes. So those organs responsible for the digestion, actually we say that the digestive system is a complex. So it means within the digestive system there's a number of 40 organs. But you may represent a single digestive system as just a simple architecture. So it is a complex unity. For instance, microcontroller unit. Say microcontroller unit.
Microcontroller.
Say microcontroller unit.
Microcontroller.
So in microcontroller unity, what do we say? It means within it we can have more than one block. Then you have what? Example, power supply unit. The first one, very important. The size. Say the size.
The size.
Say the size.
The size.
The size of the blocks gives overview of what? Of the simplicity or complexity of the actual system. So sometimes the size of the block gives you some information that this block representing a complicated system or a simple system. Are we together?
Yes.
Are we together?
Yes.
Is it clear?
Yeah.
Okay. So let us continue. After having these features, now we have just to draw examples of blocks. Example of blocks in what? In electronics engineering. In electronics what? Engineering. So listen. So I've prepared some examples of the blocks and you have to listen because I'm going to present it and actually I'm going to translate what you've been studying in terms of diagram now or in terms of blocks. So a block might be drawing like this one. So it might be drawing like this one. It's a rectangle. Sometimes a block might be a square. We didn't mention they are square, but sometimes it may be a square where all the parts are equal. Sometimes we can draw a block which is actual, it's a rectangle, but it's aligned in vertical. And each block there has a meaning. Then sometimes you can find that we draw a block which is a rectangle but horizontally, just like this. Then, so this drawing should be drawn by using a pencil and a ruler. That's the function of the pencil and the ruler. Then also sometimes a block, yes, a block might be wide and long. So some of the blocks in electronics you might find that they are just like this one. So all of these are the blocks that may represent either a simple unit, say simple unit, say simple unit, or a complex unit. When you say simple unit, for instance, in our human bodies, just if you be asked that, maybe to describe about one organ in the digestive system, it will be different when we ask you to describe all the organs in digestive system. Stop writing. Listen. This block might represent a simple unit. Say simple unit. Say simple unit. And this block might represent a complex unit. So what is of complex unit? It's a unit which consists of some other smaller units. I said stop drawing, Naomi. Complex unit is a unit which consists in some other small units. Simple units is just it's a unit, it's independent and it's a unit. It can stand itself. And it's unique or it's one. Are we together? Are we together? Are we together? And sometimes we may draw a block or a set of blocks that is representing what? Representing complex unit. Say complex unit. Complex. So sometimes you can draw a block, and this entire block, for instance, I don't want to name them, we can call it a sensor unit. Say sensor unit. Say sensor unit. But in actual implementation, or after doing the data collection and data analysis, we realize that you need different types of sensors. Okay? Different types of what? Of sensors. So within this entire or complex units that call the sensor unit, you will have a block within it. Maybe this block representing the functionality of the first sensor, for instance. Right? Then in your system, according to your design, you can have another block representing a second sensor. You can also have another block representing what? Maybe a steady sensor. You can also have another block representing the first what? Sensor used in that system. I said stop drawing, stop writing, stop bending, listen and watch. Now the story has changed. Before, the story was normal, right? But now it's another story. So we say that the block can represent a complex unit. Say complex unit. Complex. So this one, this block, represents the complex unit. It means it's a unit which consists of some other units. And those other units, hello, Mr. Backbencher, how are you? Are you fine? Sure? So, this is the first unit, second unit, third unit, fourth unit. But all of these four units have been included in the complex unit. Right? Let me give you a simple example. However, that I'll just give you for the matter of understanding. I will not write because we are not yet labeling the blocks. We are just drawing the blocks. Okay? For instance, let's say that this block represents sensor unit. Say sensor unit. So sensor unit in that particular system, for instance, in your mobile phone, we have so many sensors. So the sensor unit of your mobile phone is complex unit. Malaika. For instance, in your mobile phone, you have a sensor that's called the fingerprint sensor. Say fingerprint sensor. Say fingerprint sensor. Say fingerprint sensor. But also, in your mobile phone, you have a sensor that's called the temperature sensor. Say temperature sensor. Say temperature sensor. Then within your mobile phone, you have a sensor that detect the acceleration, which is called the accelerometer, right? And also within your mobile phone, you have a sensor that's called the touch screen sensor. Yes, it's a sensor. For you used to touch, but you don't know what's happening there. So you can notice that I've mentioned 4 sensors you see in your mobile or in the sensor unit of your mobile phone. There are so many other sensors or mobile phone sensors which I did not mention there. Are we together? Yes. But all of them, so we call them sensors. Say sensors. So it's the set of sensors. While for instance this block, we can just call it if this is also representing a sensor. If it is a simple unit, then this block we can just call it IR sensor, infrared sensor. So it's single. Although I said stop drawing, stop writing, listen and prepare questions. Left. Are we together? Are we together? So this one representing what is simple unit, and this one representing complexity. So simply this one we can call it. So this is just an example for you to understand. So this is called the complex block. Complexity complex block, and this is what is simple blocks. Say simple blocks. Say simple blocks. Yeah. So when we'll be discussing about lines with arrows, then we'll add something there. When we discuss about labels, those, for instance, within these blocks, we should not label. So now I'm going to delete the labels. Yes, you have to keep in your mind, because we are not allowed to label while we did not learn the meaning of label or putting a label in the blocks. So it just you have to draw blocks. We have been discussing all about blocks. We did not discuss about labels. But this is still incompletely block diagram. It's not a block diagram. We just discussed about block at the part of the block diagram. Are we together? I didn't say draw, but you are drawing. That's the challenge of Tanzanian students. Discipline. Did you understand? Questions about what you have discussed. So did you understand the meaning of blocks in block diagram? How many blocks will you draw? How many blocks will you draw during your ordinary diploma education? Many. Can you count them? Why can't you count them? Why can you count your age, your years of living on the planet Earth? Why can you count mandazi that you are eating in a single breakfast? Okay, so if you have understood and there is no any question, I would like to say that this is the end of lecture 1 of block diagram. And firstly, I would like to thank God who have taught me and gave me the power, authority, techniques, and the teaching aids to teach you about block diagrams. What I've prepared before I came to the class is less than what I've taught you. So simply I want to tell you that God is at work. And I would like also take this opportunity to thank you, physical students in this class and even online students. I would like to say thank you. And also I would like to welcome you in lecture 2, when we'll be discussing about the other 3 main parts of block diagrams. You have to make sure that you should not miss. If you have a friend pursuing ordinary diploma in electronics and telecommunication engineering, please invite him or her. If you have a friend pursuing, I'm talking to you while you are drawing. If you have a friend pursuing or actually studying communication system technology, please invite him or her. If you have a friend who is actually pursuing computer engineering, please invite him or her. I believe that at the end of this topic, he or she will actually remember you. If you have a friend pursuing electrical engineering, please invite him or her to come and learn together about how to draw engineering diagrams. So if that's the case, I always appreciate my students. I don't have jealous, right? So that's why I say that mwenye wivu ajinyonge sana. Iyo, yo, iyo. Mwenye wivu ajinyonge sana. Yeah. So that's one of my favorite songs, because actually it's preaching and delivering message for those jealous people. So I don't have jealous with my students. I always appreciate them for understanding, for listening, for just participating, and making me to do my responsibility of my work. So now, it's time to congratulate you, brother. It's not the time for drawing. 1, 2, 3. Hongera. Imara. Wow. Next time, come early in the class. Thank you very much. May God bless you. See you in lecture 2. Make sure you visit Tanzania Online Full Technical College to learn and enjoy the beauty of basic engineering mathematics, electronics engineering, telecommunication engineering, and fundamental of computer programming. Bye-bye.
Tanzania.